Last video for this week, crazy word problems. As for always, feel free to drop by my office hours. You can ask me any questions, email me, even college algebra questions. I've taught it before, I can teach it again. All right, here we go. So here we have a plane going from Dallas to Atlanta, Georgia. Whoop. That's 800 miles. All right. Has a prevailing west wind of 40 miles per hour. The return trip against the wind takes a half hour longer. Find the average speed of the plane in still air. All right. So we go there, it takes a certain amount of time. We come back, it takes a little bit more. It takes a half hour more. So I have a distance, I have a speed, I have something about time. So this is distance equals rate times time. But time is the thing we're going to end up focusing on, but I'll just leave it for now because we still use that to organize our table. All right, so there's two legs to this trip. We've got, I don't know, like I know there's the return trip. What do you call the first one? Well, we're going to call it the first one. Really, the better thing would be with and against the wind because that's what we actually want to focus on. So I'm going to write that in. So it says the return trip is against the wind. So first it's going to be with. Now the with versus against, the idea is if the wind is with you, then it's helping you. Just like if you go with the current, it helps you if you're on a river doing one of them paddle boat ones. So with, like this is our plane, this is the wind, it pushes it so it goes faster. The return trip, now this is our plane coming in and the wind is pushing it backwards. So that's why it takes longer. But in both of them, in math land, even though it's not quite true, we're going to presume the distances are the same. I'm just going to note the units just to make sure we keep our units. Now our rates, I'm trying to find the average speed of the plane in still air. We got to call that something, and I don't like S's because my S's look like 5s. So I'm going to go with a P for plane. So the average speed of the plane is going to be P. So when I'm going with the wind, I have my plane speed plus my wind speed. So plane plus 40. And then my return trip, it's plane speed minus 40. And this is miles per hour. Now our time. What they told me about time is the return trip against the wind takes a half hour longer. A half hour longer than what? Than the with trip. So we have, that tells us the against time is a half hour more than the with time, where this is something and something. So I have an equation here that relates my times, and I have some blanks in my table. So if I can figure out how to represent time in terms of distance and the speed, then I can fill it into my equation here and solve. So we're going to go back up here to our distance equals rate times time. I want to get time by itself. So this means I divide by the rate. So the time here is the distance over the rate. There is our ratios. So I'll use green. So this one is going to be 800 over P plus 40. This one is going to be 800 over P minus 40. So my width is going to go here. 800 over p plus 40 plus half an hour. Now I know some of you guys might be, but it's 30 minutes. Can't we just do 30 so we don't have a fraction? No, we can't actually, because that would mean we would have to change the 40 miles per hour into miles per minute then. Don't want to do that. So I know the fraction is annoying, but we got to keep it. And then our against is with the minus. 800 over p minus 40. Now, if this was a multiple choice question and you get this equation, you could take some answers, shove them in there, see which one works. You can also kind of guess and check and figure it out because usually the number's pretty. But if you were ever doing something like this in the real world, you would put it in Google and Wolfram Alpha would tell you the answer. Right, I mean, we're pretending we're back in the 60s. Then you would have to do it this way because the numbers will be ugly. All right, still same thing we were doing before. Figure out what my common denominator is, which is everything I see, all multiplied together. So I'm going to multiply by a 2, because that's another denominator. The p minus 40, the p plus 40, times 2. P minus 40, p plus 40, times 2. P minus 40, p plus 40. I know that is horrible handwriting. I'm just squeezing it in, but this is the way I go through it sometimes. I'm going to make some room. Bye-bye, Joan and Henry for a bit. All right, so the p minus 40 is going to cancel the p minus 40. 800 times 2 is a 1600. This one will be times p plus 40. Here, my 2's cancel, so I end up with p minus 40 times p plus 40. Hopefully your brain is like, ooh, 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 difference of squares. P squared minus 1600. Good Lord. Yeah, but see, we got a 1600 on the left here, so apparently that's okay. Plus 800 times 2 again is the 1600. And then the p minus 40. So we do have a quadratic, but it looks like there's only that one squared term, so this should factor. Alrighty, so 1600 p plus 16 times 4 is 64. Oh, because there's 3 O's. Good Lord, that is insanely huge. Minus 1600 plus 1600p minus 64. Oh. All right. So we're going to try to get our like terms together. So my p squared is here on the right, so I'm going to move all my stuff on the left over there. PPP minus 1600p. And notice those cancel. So I'm doing it in this order deliberately. Those cancel, so I'm actually just going to have p squared and numbers. So I can use the square root property. I don't even have to factor. So I'm going to add 64,000, add 64,000, and I'm going to add 1,600. Highly recommend calculator here, but this is the point when I get stubborn. So that's 129,600. What I don't do is square root in my head. That is where we're at. And technically, we're putting it in. So technically, it's a plus or minus. Every once in a while, you run across a weird word problem where the minus does make sense. So don't automatically check it out. But since P is actually representing a quantity in the problem, the speed of the plane, yeah, the negative doesn't make sense. So 129,600. I'm pretty sure it actually does square root nicely. And turn the phone sideways. 29600. 360. All right. So let's wind it back up here. Does 360 look like it makes sense? So if I have 360 for P, I'm going to write it to the side. Miles per hour. Plus 40 would be 400. 800 miles at 400 miles per hour is going to be 2 hours. And then against the wind, it should take longer. So then it's going to be 360 minus 40 is 320. 800 divided by 320 is 2.5, a half hour more. So here, like crunching through to guess and check and figure out what the times are can actually work out a little easier. And some people I know, they look at this and they can actually kind of like reason through and figure out, oh, it's going to be this. And I'm just like, I have no idea how you did that. Good for you. All right. So there is our answer to this one. So the whole with and against, that's the part of this. And then they give you something about time. Time is what's forcing you to use fractions. And they put the variable in the speed, so you end up with variables on the bottom. So you end up with a rational equation to solve. All right, now our other one is one of the work problems, what I called paint the fence. Actually, I said paint defense, and the subtitles had no clue what I said. But combined work problem. So whatever the job is, whatever amount of time one person does, whatever the job is, the amount of time the other person does, you add those together, it's going to equal the one job or whatever the job is and the time it would take them to do together. So we figure out their fractional rate and they're going to sum up. All right, so here they're telling me it takes Henry 1 hour longer to fill 100 orders than Joan. If they work together, it takes 3 hours to fill the 100 orders. Find the amount of time required for each individual to fill 100 orders working alone. Round to the nearest tenth of an hour. So this part says probably not going to get a pretty answer. We'll get an answer. It's not going to be like 3. Okay. So the whole idea is whatever our job is and whatever the time it takes to do that job, which this ends up becoming then the fraction of the job you can do in 1 unit of time. So once the denominators are the same, then you can add the two together and figure out what their together rate is. So here, the job they're doing is 100 orders. So I'm going to start with that, but you're going to see we actually just could have called it one job. But for now, I'm going to write the 100 orders per, and let's see, Joan. So Henry takes more time than Joan. So if I called Joan J, then Henry is going to be J plus 1. If they work together, it takes 3 hours. All right. So you see how 100 orders is on top of all three of them? So I could actually multiply by 1 over 100 or just divide everything by 100 and turn those into 1. The equation will solve either way. It's just your numbers would be bigger if you left the 100. But there are other problems where sometimes the thing they give you, like instead of asking the amount of time to fill 100 orders, they could say, what's the amount of time to fill 200 orders or 300 orders? So you do sometimes have to pay attention to those numbers. Just in this case, the 100 is actually a distraction number, basically. All right, so we are going to solve the equation 1 over j plus 1 over j plus 1 equals 1/3. So much prettier without the units. Oh yeah, but up here, these were hours. Oh, I did write it over there, good. All right, so my common denominator, everybody I see is going to be in the common denominator. So a 3, a j, and a j plus 1, a 3. Let's put that times a j, and a j plus 1, a 3, a j, and a j plus 1. I love this step. Goodbye j's, goodbye j plus 1s, goodbye 3s. So 3 j plus 1 plus 3 j's equals j times j plus 1. So we will get a quadratic. All right, so 3j plus 3 plus 3j's equals j squared plus j. So we're going to move stuff to the right. So minus 3j minus 3j and minus 3j minus 3j minus 3 minus 3. So 0 equals j squared, and then that is -6. 1 minus 6 is -5j minus 3. Now remember, they told us round. This doesn't factor. Of course, you can also look 3, 1, and 3. There is no way to get to 5. But it should work out to real numbers because they wouldn't ask the question if there wasn't a solution. All right, so in this case, instead of x equals, our variable is j, so this is going to be j equals -b plus or minus the square root of b squared minus 4ac all over 2a. Yes, every time. So now this is a +5 plus or minus. So that is going to end up being plus 4 times 3 is 12. 25 plus 12 is 37. Yes, I've watched the Jersey movies. No, I will not explain it if you haven't. All right, so 2 possible answers here. 5 plus whatever the square root of 37 is. So that's 1 more than 36. So the square root of 36 is 6. So 5 minus 6 would be negative. So she's not going to take a negative amount of time. So it's whatever 5 plus the square root of 37 is. So let us determine the square root of 37. 6.082 blah, blah, blah. So 5 plus 6.0827 over 2. So I'm going to write the minus back in, but then I'm going to cross it off because you can look at that there if you didn't realize it before. Don't want the negative. So I have that plus 5, 11 something divided by 2, 5.541. said round to the nearest tenth. So 5.5, then rewind, hours. All right, so J is 5.5 hours. Henry is one more than that. So Henry is 6.5 hours. Now I know gut reaction is, oh, and then their time together is 6. No, their time together is 3. The time together time has to be smaller than their individual times, both of them. And that's because if it was 6, then Joan could just do the whole thing on her own in 5.5 hours. Why would she work together with Henry for 6? Like, that's always my explain to myself why it's not the average, even though my brain still does it initially. Average, no. All right. That is it for this week, my lovelies. Oh, lots of crazy work. All right. Have fun graphing your polynomials, and next week we will have the madness of rational functions. Feel free to stop by and ask me questions. I find them kind of fun, but I also know lots of tricks for them. Bye.